Magnitude, direction, and components of a vector. Alright, let's suppose that I have theta between 0 and 360 degrees and I have vector v, which I forgot to label right here. This is vector v right here, okay? And it talks about theta is the angle to measure and is measured and we consider going counterclockwise like we normally do, okay? Then it talks about the magnitude of this vector v is like we said. It's the square root of a squared plus b squared. And this would be like the point a comma b right here, this terminal point. Okay? Then it talks about the tangent of theta is equal to b over a. Now where did that come from? Okay. Right here. What's the length of this side of my triangle if I draw a triangle here? Isn't it the same as this B length right here? So I can call that side of my triangle B. What is the length right here of this side of my triangle? It's the same as A is, right? So I can call that length A right there, right? So if I look at this as a triangle, what is the tangent of theta? It's B over A, right? Or you could think of it as what? The y coordinate over the x coordinate, either way, okay? Now let's see what A and B are as far as my components in the vector, okay? Well, how can I find that, okay? Let's see. Let me erase all this stuff up here so I can find it. Alright, so what do they want? They want A and they want B. Like, in my components here, what is A and what is B? Because that'll give me vector B, right? Alright, so let's look at this triangle, and let's use some trig functions, okay? What if I think about the cosine of theta? Wouldn't the cosine of angle theta be in this triangle A over this right here? A over, and what is this if I'm looking at the length of this triangle? This is actually the magnitude of vector B, isn't it? So I'd have A over the magnitude of vector B, because we're really looking at what? Length over length, aren't we? Alright, so what happens whenever I multiply both sides by this denominator? I get the magnitude of vector v times the cosine of theta is equal to A, or I could say A is equal to the magnitude of vector v times the cosine of theta. Well, if that's A right here instead of A, what could I call that? I could call that the magnitude of vector v times the cosine of theta. Now let's come up with something for B, okay? Again, I could use trig and say the sine of theta is B over this magnitude of vector V. Actually, I'm going to need to erase a little bit here. So I could say the sine of theta is equal to the length of this side of my triangle, which is B, over the length of my hypotenuse, which is the magnitude of vector v. And if I multiply both sides by the magnitude of vector v, I get B is equal to the magnitude of v sine of theta. So B I can replace with the magnitude of vector v times the sine of theta. So what are we saying? We're saying vector v in component form is AB, but I can find those components A and B by calculating the magnitude of vector v cosine of theta, magnitude of vector v sine of theta, okay? That's what they're trying to say right there. And they say this also. They say or I need to erase some more stuff. Or we could say this. Vector v is also given by A times I plus B times J. If I want to put these components, or if I want to write the vector in terms of the unit vectors I and J, okay? And another way to write this would be, instead of A, what do we call A? The magnitude of vector v cosine of theta was A, right? Times I, times vector I, plus B, which is this stuff, right? Magnitude of vector v times the sine of theta times vector j. That's another way I could express v if I wanted to. All right, so think about that step, and we're going to use that for our homework problems that are going to look something like this. Look at your next example on the paper, okay? What's your next example read? Write the vector v in the form ai plus bj. Okay, so our example, we have vector v, or the magnitude of vector v, is 18, and then they tell us that theta is equal to 150 degrees, okay? And what do they want me to do? They want me to write vector v in the form ai plus bj. So vector v is equal to a times the vector I plus b times the vector j, right? All right, so let's find a and let's find b. That's what this basically boils down to, okay? How do I find a? What did we say a was equal to? The magnitude of v, or the magnitude of my vector, I should say, times the cosine of theta. The magnitude of my vector times the cosine of theta, right? So what does this calculate to be? What's the magnitude of v? Oh, how sweet, they give that to us, 18. Times the cosine of theta, which is 150 degrees, right? So what does that give me? 18 times, now think of 150 degrees. What is 150 degrees? 180 back off what? 30 degrees? So what do you have? You have a unit circle, basically, and you look at it at a reference angle of 30 degrees. So which point are you at right here? You're at negative square root of 3 over 2, comma 1/2. So what's your cosine there? Negative square root of 3 over 2. So what does this give me? Negative 9 square roots of 3. All right, so I found A right here. Let's find B. How do we find B? Well, the way we find B is we say what? B is magnitude of B times the sine of theta. So vector, or I'm sorry, component B is going to be the magnitude of B times the sine of theta, it said. Magnitude of B, they told me was 18. So 18 times the sine of theta, or the sine of 150 degrees, right? So that's 18 times, what's the sine of 150? 1/2, so that gives me what? 9? Alright, so now what am I finding? They're telling me to write that thing in this form. So they're saying, I want to write in the form A times vector I plus B times vector J, right? So let's see, that's A, which we just calculated to be what? Negative 9 square roots of 3 times vector I plus B, what do I find B to be? 9 times vector J. There we go. I wrote it in that form. That was page 8. If I can find page 9 in my notes, I'll be good. Okay. Page 9 now. Woo! This is a long section. In fact, this is going to be broken up over 2 days here. All this is leading to something, okay? It's leading to these nice, pretty, or maybe not so pretty word problems, okay? So get this stuff down so you're able to do the word problems that are coming next. All right, our next example is find the magnitude and direction angle where theta is between 0 and 360, round to 1 decimal place. All right, so they have V is equal to the vector I minus 0.8 J, okay? Now, what is this if I want to write it in a form A comma B in the component form like that? Wouldn't it really be just 1 negative 0.8? Let me convince y'all of that real quick, okay? Alright, so is it vector B, if it's this, isn't it really 1I minus 0.8 J? Well, isn't it the same thing as 1 times vector I is what? 1 comma 0 component form? minus 0.8. Vector j is just really 0, comma 1 in component form, right? So isn't that 1, comma 0? And then if I distribute this negative 0.8, I get 0, comma negative 0.8. And if I add these two vectors, what do I get? I get 1 plus 0 is 1, 0 plus negative 0.8 is negative 0.8, right? So that's the way to represent this vector v in component form, okay? Alright, what do they want us to do here? I forgot what they want us to do. They want us to find the magnitude and direction angle, okay? So how do I find the magnitude of vector v? Well, I could simply say that's a square root of, what was the formula they gave us earlier? A squared plus b squared. So that's the square root of my a value, which is 1 squared, plus my b value, which is negative 0.8 squared. So that's what? 1 plus, what is that, 0.64? So that's what? Square root of 1.64. So what does that give me? Approximately 1.2806, because they're going to want me to round anyway, right? Alright, so what do they want? They want the magnitude, which I just found, and the direction angle. And the direction angle of this vector. Alright, so let's look at this vector. We said this vector in component form, this vector v in component form is 1, comma negative 0.8. Alright, let's see what that looks like. If I graph this, it looks like 1 unit this way, negative 0.8 that way, so it's going to look something like that, right? Now what I want is I want this angle right here, theta, between 0 and 360 degrees, okay? So what did they tell me earlier? They told me the tangent of theta is equal to b over a, right? So whenever you calculate this, what you're actually going to calculate is you're actually going to calculate this acute angle right here. So technically that should be theta prime that we're finding right now. Theta prime. We're finding theta prime. So the tangent of theta prime is equal to b over a. B over a is negative 0.8 over 1, right? Or we could say the tangent of theta prime is equal to negative 0.8. And we could say theta prime is equal to the inverse tangent, or the arc tangent of negative 0.8. Alright, now, be very, very, very careful here, okay? Because they told us that what? They told us at the beginning of this problem, theta is between 0 and what? 360 degrees. So I definitely need to make sure that my calculator is in degree mode. Make sure it's in degree mode, then you take this, okay? So if I do so, I get theta prime is approximately 38.6598 degrees, and that's a negative. And the whole reason it's negative because in this quadrant the tangent's negative, right? So that's this value right here, right? How do I find the actual theta value from here to here? Wouldn't it be 360 degrees back off theta prime? So 360 degrees and then back off this much, which is what? 38.6598 degrees. So if you do that, you get theta is approximately 321.3402 degrees. And let me sum up what I found. They wanted me to find my magnitude of my vector. So the magnitude of vector v, and they want me to round the answer to 1 decimal place, is approximately 1.3. And what else do they want me to find? The direction angle, theta. So theta is approximately, if I round to 1 decimal place, 321.3 degrees. Alright, so that's the first part of the lecture. Second part will be another day.